Thank you very much. So like all my colleagues, I could obviously go on about this for hours, so I'll just be picking out a few highlights. And since it's a business partners event, I want to try to bring out one or two business implications of this technology and not just give you a technology talk. I should say that we didn't collude before this event. We prepared our presentations separately, so if they all kind of mesh together quite nicely, that might tell you something. Although John and I agreed that if we contradict each other wildly during the evening, then that could be quite a good thing, because that'll get some debate going, which I'm sure you'd all like to have. So my job is to provide these millions of sensors that are going to enable this data-driven revolution that the previous two speakers spoke about. And most of these devices come out of our lab. If you think about putting intelligence into an environment, you really need to do several things. You need to generate the information, which is effectively sensing. You need to process and store that information, which is computation. This is the traditional semiconductor industry, so this is not one of our devices. It's just a standard chip. And then you need to move the information around by optical or wireless methods usually. So these are, the outer two are things that we do quite a lot of, and most of them are done in silicon, apart from this one. So this is a silicon motion sensor, for example. Now, silicon sensing has come a long way in the last 20 years. And the example that I'd like to talk about quite a bit in this talk is this one, the silicon accelerometer, which is an acceleration sensor, which you all have probably several of in each of your phones and gadgets. It's a very sophisticated device, high performance. It's very small, very low power consumption, and extremely cheap to manufacture in quantity. But it was not developed for the phone application. It was developed for this application, the triggering of automotive crash bags. And the reason is that this was a very clear market and investment case because it was driven by legislation. Everybody knew exactly how many cars were produced every year. Everybody knew exactly, therefore, how many sensors they were going to need and when they were going to need them. We also knew the requirements, particularly the requirement that the sensor be extremely reliable, because the last thing you want, particularly in the US, is to make a sensor that doesn't trigger the crash bag at the crucial moment, because that's probably the end of your company. So what can we learn from all that? Well, what happened then was that the investment case having been made to generate the sensor for that application, that became a sunk cost for every other application. And then the phone people said, why don't we put these acceleration sensors in our phones as well? We don't have to pay the development cost. It's already done. Initially, the reaction was, I remember at the time when it happened, most of people in the phone business thought, what on earth do we want an acceleration sensor for in our phones? You know, you're not going to throw it across the room and try to make a tracking device. But it started with very simple things, like an acceleration sensor can also detect the direction of gravity. So it can detect if you're holding the phone up to your ear, then maybe you can turn the display off, save power. It can tell if you've laid the phone flat down on your desk, again, turn the display off, save power. But then once you've got it, you can start to do more sophisticated things like gaming and navigation and so on. So you can draw some interesting general conclusions from this, I think. We've put a lot of sensors in systems for a long time. So in automation of production systems in chemical plants, for example, of course, they would never run if they didn't have quite a few sensors on them. But the revolution in sensors is not just more of the same. It's not just let's have 200 sensors instead of 50 sensors. There's lots of different sensors of different quality and reliability. Rather than being able to rely on every single sensor absolutely, we can now put hundreds of sensors where before we had 3. We can put in sensors for one application and use the data for a completely different application because the data can be uploaded to a common platform, and we have systems in place to do that. So that's another quite interesting thing, I think. And the networks themselves are very dynamic, constantly devices being added and subtracted from them. Now there is a problem, which is if you've got zillions of devices wirelessly implanted all over the environment, then you would like really the power to be wireless as well, because you don't want to send somebody around your bridge, if you take Mark's example from a moment ago, and replace the batteries in hundreds of sensors every month. So we've been working quite a bit at Imperial on powering sensors from the environment. So this is a little tiny wind turbine that you can put this coin size that you can put in ductwork and HVAC and so on. This is a thermoelectric power unit which uses the up and down of temperature in an aircraft from on the ground to in the sky, and this is being used to power some strain sensing for structural health monitoring of aircraft. It was a project we did with Airbus, which has been up in flights now. And this is a little rocking mechanical sensor which is really developed for body-worn applications, but also has some applications in vibrating machinery and different things like that. So this is quite an interesting aspect of making this sensor revolution possible. What do we want all the sensors in the environment for? This actually comes out of a project that half of us that are speaking to today, and David, we all worked on together a few years back. Coping with peaks, so most infrastructure really is invested on the basis of its peaks, not on the basis of its average usage. That's true of certainly very much in the communications field, in electrical power. So it would be very good from efficiency and investment reduction if we could smooth peaks, move them around and use them more effectively. And of course, information is a very good way of doing that. The more we can move information around, the more we can predict usage, the more different usages can know about each other, the more we can offset different uses against each other. That gets quite interesting. And you get, for example, in the home, this is something that's been tried periodically over several decades, is to try to, for example, do dynamic pricing in order to shift usage patterns. People are not very sensitive to dynamic pricing because they value convenience above everything. And so this suggests that what you really need is a high degree of automation. So nobody's going to want to manually go to their phone and turn their washing machine on because they've just got a text saying that the price of electricity went down by 2p for the next half an hour. But if you can automate all that, then you need to trust your automation system and you need to trust the algorithms, and they are probably supplied by some third party like Google, Microsoft, etc. And then you get into this kind of thing. But you can imagine that a software type provider becomes your energy provider. Now, this has already happened to a great extent in communications. If you want to send information, or certainly a generation younger than us wants to send information, they think of a provider not as BT, but as WhatsApp or all these other things they use. I actually use WhatsApp myself, so I know about that one. But the interesting thing about WhatsApp is WhatsApp owns no communications infrastructure. Skype, which is, I don't know how much Skype is valued on the stock exchange, but tens of billions probably, they own no communications infrastructure. They just sit on top of the infrastructure providers and pull lots of profit. This has been a great frustration to people like Vodafone and BT and Telefonica and so on, because they feel they're turning into sort of dumb pipes and all the fun stuff is being robbed from them by these over-the-top players. I think it's, and they've struggled with this kind of trying to do something about it for many years. I think it's time to give up on trying to do something about it and just accept that actually the user, at least the consumer-facing part, is maybe better done by somebody who specializes in that. And just make sure that if you're going to be the underlying infrastructure, even if you're invisible to the end user, you can still have a very good and very profitable business doing that. And so, does it matter if the consumer buys electricity from the sort of WhatsApp of the electricity market? Maybe it doesn't, right? Why should it? Can you build a major train company without owning any track or rail infrastructure at all? Probably you can, yes. It probably is going to happen. Okay, so that's the path. We start with crazy little devices developed at vast expense for applications that you've probably forgotten about or didn't know, but then they migrate into all kinds of crazy things. We build smart devices, we put them together to make smart systems, we link them up to make smart cities, environments, and all the applications that all my colleagues are telling you about follows from that. What do consumers, if we want to talk about consumers, expect from all this? It's getting pretty clear. Because things have been provided to them by certain sectors, by travel, communications, and so on, like instant information, no need for advanced planning, automatic decision making, and ultimate convenience, they are starting to demand that in every other industry as well. And if you're not providing that in your industry, then somebody else is going to come along and do it, and they're going to take your business away from you. Thank you.